The unifying force is that you need the ontology object, the graph object, to actually tie all these abstract entities from the system of record into one unified digital twin. And that's why this type of concept is very powerful. And this is the great unifier of all the systems of record in a company into the digital twin. And why is having a digital twin very important or very exciting? It's because now with that information, you could do things like simulations and scenario planning and all sorts of things that one could not do before in this like narrow SaaS world. But of course, there's great amount of complexity in setting such an object up. And that's why I think a company like Palantir has to sell these $10 million contracts to really drive things forward. And the most sophisticated organizations, only the most sophisticated organizations could really afford to use that. Welcome to Agentic Data, episode 14. Agentic Data is a podcast about data and AI. And I am your host, Joseph Moon, CEO of Oxygen Intelligence. And today, we'll be talking about a news topic and a research topic. Let's first talk about the IBM acquisition of Confluent. Let me pull this up. So what we're seeing here is a LinkedIn post by Arvind Krishna, Chairman and Chief Executive Officer of IBM. The post reads, "Today, we are announcing that we have entered into a definitive agreement to acquire Confluent. This is a decisive step that accelerates our hybrid cloud and AI strategy. It builds an intelligent, always-on core that moves trusted data and insights in real time across environments, applications, and APIs. Data movement in real time is really the key here. Companies want to run operations in real time. Transactions happen in milliseconds. Supply chains adjust instantly. Fraud is detected as it occurs. AI, in particular, magnifies the value of real-time data. Models are only as strong as the signals feeding them. As more companies deploy AI agents, digital workers, and autonomous workflows, they depend on live, not static data signals. At the same time, the amount of data moving through enterprises, the number of applications being built, and the role of AI in daily operations are all multiplying by orders of magnitude. AI agents and autonomous systems now require fast, continuous access to data to function. This is opening one of the largest new infrastructure opportunities of the AI era. And it builds on the trusted data integration capabilities enterprises already rely on to run their core systems. Real time is now becoming equally critical alongside these foundations. Confluent's platform moves data from where it is created to where it is needed in real time. It extends our existing capabilities and completes the foundation for an end-to-end smart data platform. Together, this gives clients a way to move, manage, and act on data across batch and real-time systems working as one. Confluent accelerates what we already do for our clients across data, open source, integration, and AI. It extends our ability to help clients move from insight to action instantly across complex hybrid environments. It also builds naturally on our long-standing commitment to bringing the most powerful open source technologies into enterprise use, from Red Hat to HashiCorp and now Confluent. This move is consistent with IBM's growth strategy. We use both organic growth and targeted M&A to strengthen the platforms our clients rely on most: hybrid cloud, automation, integration, security, and AI. Confluent follows the same disciplined playbook: identify category-defining technology, integrate it deeply, and scale it globally. I'm confident this is the right move for the future of both companies, and I look forward to welcoming Confluent's employees to IBM once the deal is finalized. Well-written, highly strategic, pretty insightful. I think one thing to note is that Arvind Krishna is not your typical IBM sort of legacy megacorp executive. So if you look at his profile, he went to IIT, extremely cutthroat to get into one of the highest sought after universities in India, and a PhD in electrical engineering and computer engineering in the late 80s to the early 90s. And he spent 35 years first being a researcher to being a general manager of software, being SVP of hybrid cloud and director of IBM research, and finally, chief executive officer. And so Arvind has a strong research DNA that is really propelling the future of IBM. I think last episode, we talked about the importance of research as an enduring moat in this day and age. Research and customer service as the only remaining moats in enterprise AI. And his background perfectly captures what is necessary to really push IBM forward. I think IBM was at the forefront of AI research back in the day, maybe 1 or 2 decades ago. It kind of stumbled as new players like OpenAI and Google DeepMind, et cetera, really came into the scene, so to speak. But I think it's really playing catch up using very aggressive M&A and also using its enterprise distribution channel and its consulting arm to really push things forward. I think another company that's very good at this M&A play is Salesforce. But the difference between Salesforce and IBM, there are a few differences, many differences. But it does look like IBM really has a core research DNA driven from the top, whereas Benioff looks like more of a visionary and storyteller and just an amazing salesperson, which really probably worked well in the era of enterprise software driven by the cloud, because the cloud was a movement that did not require a huge amount of imagination, whereas in AI, imagination and research understanding is really key in driving adoption forward. So I think the enterprise software days of enterprise Salesforce really leading the way. But I think this new era will likely be driven by, yes, sales and customer service, but at the same time, great research. And IBM having a strategic consulting arm to do a lot of strategy consulting, as well as integrations, systems integrations work, really gives them a great advantage over companies like Salesforce that have to rely on third-party consulting companies like Accenture, Deloitte, et cetera. So I think IBM definitely has a systemic advantage over a company like Salesforce. And so that's very interesting. And I think from Confluent and HashiCorp's side, both being, I think, publicly traded companies around the $10 billion range, and then having entered into an agreement to be bought out by IBM, I think one thing is clear that the capital markets are ruthless and efficient to some degree. And when the growth stalls out, then I think companies are very much punished for the growth stalling out. And I think in particular, infrastructure companies, if they start working, they work really, really well. Infrastructure companies are very, very sticky. There is great net account expansion in enterprises as more and more workloads get on top of this platform. But enterprise infrastructure companies also sometimes struggle to go multi-product, because I think whereas if you're an application company, you could kind of see the adjacencies in your business. So like if you're Salesforce, you started off with a CRM, and you could kind of see that, okay, Salesforce optimization and orchestration is adjacent to customer service and also marketing as well. These are all functions that are adjacent in a company. So it's easier to see the adjacencies. Whereas I think in a infrastructure company, infrastructure allows one to run many, many different types of workloads, but you're not really close to the end application. You're really concerned about running more and more compute onto the platform. Notoriously, it's hard for infrastructure companies to really go up to the application level because the DNA is really not part of the company to get into applications. So DNA-wise, there's an issue here. And also going multi-product is really difficult because engineers are way more religious about the infrastructure that they build compared to applications, maybe primarily because the engineers building the infrastructure they're also their own customers, and so they have a deep tie to infrastructure. So it's something like infrastructure is highly defensible when it works well, but the very thing that gets it to this religious type of adoption in the market kind of taps you out if you're not able to go multi-product. And a company that went multi-product really successfully is Oracle, in going from MySQL to applications and so on and so forth. That's a kind of an older company that did it quite well. Salesforce obviously did quite well in terms of going multi-product on the application layer. I think Databricks and Snowflake, they do not want to be what Confluent is today. They don't want to stall out at, say, like $1 billion of revenue and call it quits. They really have to be something like an Oracle, multi-product, multi-infrastructure, multi-lines of businesses, so on and so forth. And to do that, you really need a CEO that drives the organization forward in either very aggressive M&A grow or really push the internal engineers and product folks to go multi-product. And that requires a lot of conflict, requires a lot of vision, and a lot of pain, I think. So good for IBM on executing this type of strategy for growth. I think these rare individuals who combine research and sales and customer understanding, I think these are the CEOs that will really drive towards the future. And that's why folks like, say, Elon Musk, Jensen Huang, these more engineering and research focused CEOs with the vision and with the sales charisma, those folks are very well suited for this type of job. Okay. So moving on to a research topic. So today I want to talk about ontology as knowledge graph and a digital twin of an organization. So I think the ontology, semantic layer, semantic ontology, all these things are really hard to understand concepts, maybe overly abstract. And a lot of companies try to popularize this, but I think, as we said before, I mean, there are two types of companies that were really able to push things forward in this regard. One is the BI companies like Looker and Omni. They were really able to drive home the importance of semantic modeling to get to better metrics, dimensions, and measures, and really become a single source of truth and a system of record for metrics within an organization. I think Palantir is doing a good job in pushing forward this ontology as like a much heavier and all-encompassing concept for an organization. And I think for Palantir, the understanding that the ontology governs, let's say, the entire battlefield for the Department of Defense makes a lot of sense. Like, I need to understand how many tanks I have, where is it, how many personnel do I have, where are my aircraft carriers. All these things should be mapped out, and I need to understand the relationships between all these concepts. And with powered by these relationships, then I could build sort of these high-level dashboards that really drive decision making. So that makes a lot of sense. And let me get into, I think, the sort of the narrative arc that Palantir has used quite well in explaining the necessity for something like an ontology that is effectively just a semantic layer really exploded into unifying all concepts and effectively is a knowledge graph. There are many other knowledge graph companies as well that have tried, but I think the knowledge graph has to be coupled with an application layer. It's just like how the semantic layer has to be coupled with the BI layer. Otherwise, the semantic layer is kind of useless. And I think the semantic layer and the ontology, these are sort of middle layer infrastructure. So it's not quite the data layer of the infrastructure, sort of like a middle layer. And for these middle layers to persist, you need strong application necessity to really drive things forward. So let's take a look here. Okay. So if you think about a business setting, you have a bunch of business entities that are important concepts into business. Maybe there is some notion of employee. Maybe there's some KPIs that are important to you. Maybe there's some engineering CI/CD concepts, ability concepts. Probably hundreds, if not thousands, or tens of thousands of these high order, first class citizen nodes in your enterprise graph. Your business is really the relationships between all of these entities, and you're trying to make best decisions out of these entities. And so, just latently, this is actually how things work in reality. But I think what happens in practice is that folks are trying to just model out things using just very rudimentary SaaS software, like SaaS for sale, SaaS for marketing, SaaS for customer success, so on and so forth. So like your entire business gets flattened out into something extremely reductive, maybe hundreds of these SaaS applications. But they're kind of flat, maybe like flat projections of what reality is, which I'll call reality in this like capital X. Reality gets projection mapped into like R2, some really ridiculous thing like this. It's a very lossy projection. And so really what's happening is the real world is really operating in this higher dimensional like semantic ontology space. But in actuality, what's happening is you're running your entire business from a combination of these SaaS tools as well as like bunch of, I guess, humans running around. So currently the business landscape is like a combination of like SaaS tools and humans running around. Is, very famously, Elon Musk calls this a cybernetic organism. So like an organization, a company is a cybernetic organism um, of software and humans working together. And of course, in the new brave new world of agents, you're going to have a combination of just agents running around, squares. You're going to have humans, and then you're going to have agentic software. So agentic software, which we said, it's just a combination of headless software plus agents. So this is a new type of system. And the new reality is probably going to look like this. You're going to have a hybrid cybernetic organism that is made up of agents, humans, and agentic software. And I think the whole governance structure, so imagine if I had my agents, alpha, humans, age, the agentic software as theta, this set of things, sort of the pairwise relationships between these objects have to be governed by a graph, effectively. And that graph, it's called as like mathcal G, um, is a thing that governs the properties between these guys. And of course, like one instantiation of that graph is it could be considered a matrix with some edge weights and so forth. And so maybe a matrix is what we could think of what this G is. But in actuality, the way to think about it is that this G thing is actually an ontology of different objects, different agents, humans, and agentic software, and all these things. Things are hierarchical, so some things might have, bigger weight than others, and so forth. So that's sort of what this new world is. And so, actually, the entire organization could be modeled out by alpha, the H's, and betas, that set of all objects. Actually, let's call these objects like mathcal O, and the graph based on O. So I'll call this mathcal G sub O. So actually, if you have these objects, it's mathcal O and G O, this thing defines the entire organization. And I think we could probably call this thing the digital twin of company C. Okay. And I think that is the high level overview of like the importance of the ontology and why these abstract objects could be mapped out. The relationships between the abstract objects and the abstract objects themselves constitute the entire mapping of a whole company. And if we were very abstract about it, and as mathematicians and computer scientists, one could be very abstract about it. If you understand all the information about how a system works, then you know the whole system, and that's a digital twin of the system. That's really sort of one reductive argument of this digital twin concept. So everybody knows about the entities. These entities these O objects are sort of already defined by, let's say, the SaaS software and things like that. So the system of record companies already have this O object. But what is a unifying force is that you need the ontology object, the graph object, to actually tie all these abstract entities from the system of record into one unified digital twin. And that's why this type of concept is very powerful. And this is the great unifier of all the systems of record in a company into the digital twin. And why is having a digital twin very important or very exciting? It's because now, with that information, you could do things like simulations and scenario planning and all sorts of things that one could not do before in this like narrow SaaS world. But of course, there's great amount of complexity in setting such an object up. And that's why I think a company like Palantir has to sell these $10 million contracts to really drive things forward. And only the most sophisticated organizations could really afford to use that. And so there you have it. I think one profound thing that's happening is sort of this, let's call the SaaS world, like the abstract SaaS world. This one, let's call this like mathcal O, old world of just SaaS tools running around and humans running around, and then this new brave new world of agents and agentic software and so sort of things. Let's call this new. So actually, one could just simplify this entire situation into the following, which is, hey, we're actually going through this transition of going from this MathCal O old, this MathCal O new, and then coupled with the ontology, this G O new. So we're going through this particular transition here. And if, let's use the pi old I, this set is a set of sort of the applications that could be used that are powered by this old abstraction. You obviously have this transition of the application side as well. You have new applications, pi j new, that are powered by this new type of infrastructure or this object called ontology. So this is sort of the phase transition that we're going through now. And of course, from this perspective, we're going to have to refactor. If we really believe in this transition period, we're going to really have to think about agentic software and the paradigm of applications in a new manner. So there you have it, folks. This is episode 14 of Agentic Data. We'll see you next time.